Welcome to this explainer. We're diving straight into the heart of a chaotic production server to demystify the Linux file system once and for all. Whether you're an engineer on the front lines or a tech executive focused on system reliability and minimizing downtime, understanding how your system actually operates under the hood, that is completely non-negotiable. So let's get right into it.
Imagine this. The alert clocksons are firing, a critical application is down hard, and you SSH into the server. You type ls/, and boom, you're staring at this intimidating wall of directories. You've got bin, boot, dev, etc., and a dozen others just staring back at you. For the uninitiated, this is exactly where panic sets in, and we all know every second of confusion equals incredibly costly downtime.
So here's our live debug scenario for today. Your core application cannot find its configuration file, and server reliability metrics are plummeting by the second. Where do you even begin to look? Well, the confusion stops right now. Over the next few minutes, we're going to map out exactly what every directory does, why it exists, and precisely where critical files belong so you can restore service instantly.
Let's start with the big picture, the unified tree.
We really need to fundamentally change how you picture file storage. If we run the tree command in the terminal to visualize the structure, you'll notice something right away. Unlike Windows, which uses those fractured drive letters like C and D, Linux enforces a single, unified tree. Absolutely everything hangs off a single root directory, which is represented by just a simple / right at the very top.
And this single root brilliantly illustrates the File System Hierarchy Standard, or FHS. Now, from an executive and operational standpoint, this standard is the holy grail of server reliability. It's a universal map. The truly beautiful thing here is that this strict standard works exactly the same across Ubuntu, Red Hat, and even right inside your Docker containers. You learn this map once, and your team can predictably navigate literally any infrastructure in the world.
Next, let's break this down into an action-based framework, starting with the directories you primarily read from. Think of these specific directories as your core read-only toolboxes. First up, /bin. This holds your essential everyday binaries like list, copy, and move. Then we have /sbin, containing the heavy-duty system admin tools restricted strictly to the root user, things for rebooting or configuring firewalls. Moving down, /usr is where the vast majority of your installed user programs belong. And finally, /lib. This contains the shared libraries, which is essentially the foundation all these other programs depend on to function without crashing.
Now, here's a surprising pro tip for modern infrastructure. The traditional split between these directories is actually merging. If you dig into a modern server, you're going to notice that /bin is often just a symbolic link pointing over to /usr/bin. So if you spot weird shortcuts acting as directories during a system audit, don't panic. That is totally normal, expected behavior.
Moving on, in our action-based framework, let's look at the directories you actually write to.
This is where your dynamic data lives. Every standard user gets their own personal space in /home. But notice the isolation here. The root user gets a heavily guarded /root directory. From a security and reliability standpoint, keeping this isolated is absolutely essential so an admin doesn't accidentally nuke the entire company's database while making a simple edit. We also have /temp for temporary scratchpad files, /var for highly variable data, and /opt for optional manual software installations.
And here is the crucial takeaway for both engineers and leadership. During an outage, your team is going to practically live in the /var/log directory. When a server goes down, running a command like tail-f on your system log is absolutely the fastest way to reduce your mean time to recovery. It gives you a real-time monitor of exactly what is failing the very second it fails. Now let's explore what are known as kernel windows, or virtual directories. Think about the difference here. Regular files are physically written out to your server's hard disk, right? But virtual directories, like /proc for active processes, /sys for hardware, and /dev for devices, they are completely different. They're actually illusions. They do not take up actual disk space. They are live, in-memory feeds generated directly by the host kernel. And this is exactly why modern container deployments can be so incredibly lightweight and efficient.
Let's shift gears to decoding file permissions and making Octomath easy. File permissions constantly trip people up and trigger unnecessary security audits, but I promise, it all comes down to simple addition. When evaluating security, you break users into 3 strict groups: the owner, the group, and others. For each tier, you assign a value. Read access is worth 4, write is worth 2, and execute is worth 1. You literally just add those values together for each category, and boom, that generates your magic octal number for system compliance.
Bringing this into the real world, here are the 3 security profiles you absolutely must enforce. 755 gives the owner full control while letting others securely read and execute, which is perfect for deployment scripts. 644 lets others read but not write, which is your standard for configuration files. But for security compliance, 600 is your zero trust mandate. 600 means only the owner can read and write. Everyone else is completely blocked. You have to use 600 for secrets and SSH keys, because the system will silently and very frustratingly refuse to connect if permissions are even slightly too open.
Let's tie it all together with a DevOps file cheat sheet. Exactly where do your files live?
If you take away just one thing today, keep these locations in mind, because this is your ultimate diagnostic cheat sheet. Let's go back and solve that live debug scenario from the very beginning. Your app couldn't find its config file? Well, application config files universally belong in /etc. Is your application crashing? Go straight to /var/log. Need to audit an installed binary? Check /usr/bin. Once your team internalizes this predictable FHS pattern, your troubleshooting shifts instantly from panic to precision.
To recap, you now have the map to the server.
The main takeaway here is that you absolutely do not need to memorize every single folder on a Linux machine. You really just need to understand the logic of the single root tree, the universal standard, and strict file permissions to keep your systems online and secure. But now that you've mastered where things live, the real question is how quickly can you manipulate those files when the pressure is on? Are you ready to navigate this map using power CLI commands like grep, awk, and sed? Well, that is exactly what we'll break down in our next explainer. Stay curious, and I'll see you there.